I'm Laura Podolsky. I serve as the Policy Director for the National Center for Sustainable Transportation. It's one of my favorite topics, and looking at the audience coming today, I hope it's one of your favorite topics too. The National Center is actually a consortium of 6 universities that have come together to advance a more environmentally sustainable transportation sector. I'm also proud to say that the Institute of Transportation Studies at Davis is actually the lead of this 6 university consortium. I'm also proud to say that we are one of 5 national centers designated by the U.S. Department of Transportation, and we are the only national center that's being led by a California university. So we're really excited at Davis that we're able to bring one of these national centers here to California. So today this is a part of the UC Davis Capital Speaker Series. It's an effort to make sure that we're bringing over our latest and greatest research to share that with you all and provide a benefit to the Capital community. So again, we hope that you take something away from today's presentation, but we're also here for our own purposes as well, because we really want to hear from you. So there will be some time for a Q&A and discussion. So it's really important for us to hear, what does this research mean for policy and practice? And you are all the experts on that. So we really hope that we can engage in a conversation with you all following Dr. Handy's presentation. So one word on lunch. Lunch will be served afterwards. You can walk over to room 125 and grab your box. And then restrooms, I think everyone knows where the restrooms are, but they're just out this door to the right down the hall in case you need that. And with that, I am going to introduce Dr. Susan Handy. Not only is she the director of the National Center for Sustainable Transportation, she keeps herself busy at UC Davis by also being a professor for environmental science and policy department at UC Davis. In addition to all the great work that you're going to hear about today, that she's looking at the effectiveness of various transportation and land use strategies on reducing greenhouse gas emissions. She's also doing work looking at more largely at travel behavior, as well as bicycle research, which I think you have to look at. If you're studying transportation at UC Davis, you have to look at that. And I was just thinking, if any of you need a great way to wake up in the morning, just do a commute through UC Davis campus, and that will surely do it. I know it does for me in the morning. So a lot of bicycling at UC Davis. So with that, Susan, I'd like to invite you up here, and you can all join me in welcoming Dr. Susan Handy.
Nice. Well, thank you. Thank you all for being here today. I'm going to talk about the science behind sustainable community strategies. This is a talk I did some time ago at ARB, so it'll look a little familiar for some of you, but I've added some good new stuff, I promise. So I don't think I need to tell you that the motivation behind the research that I'm going to be talking about today is SB 375, which of course set targets for reducing greenhouse gas emissions in metropolitan areas, essentially by reducing driving. So all of our metropolitan areas have by now adopted these sustainable community strategies. But the big question still is, how do we know it will work? How do we know what combinations of strategies will achieve these targets? How do we know that what the NPOs have put into their sustainable community strategies are going to get us to those targets? So that's what I'm going to talk about, this how do we know question. So of course the metropolitan planning organizations do modeling of their SCS. They use their regional travel demand forecasting model to plug in their policies that are in the SCS. And they use the model to predict how much VMT is there going to be, how much vehicle miles traveled is there going to be, and then what does that mean for greenhouse gas emissions. So that's one way we get a sense of whether this is going to work or not. But there are some caveats to this. Of course, these modeling results are dependent on the assumptions that go into these models and how good the models themselves are, and that's always a question. But also, not all of the strategies that we're talking about in these SCSs are really captured in these models, that these models are not very effective at helping us understand what the impact of some of the finer grained strategies might be. So kind of given all of that, the Air Resources Board, in their great wisdom, commissioned me and my colleague Marlon Bornett, who was at Irvine and is now at USC, to dig into the empirical research on a long list of strategies that the regions are considering as a part of their SCSs. So what I'm going to share with you is not a lot of the details about this work, but sort of some of the bigger issues around the evidence that we reviewed. And I do want to note that there were a lot of people helping us with this work, graduate students and postdocs, both at Davis and at Irvine and USC. So we ended up looking at 23 different strategies. There was a set of land use strategies, you can see those there, and then another set that we call infrastructure and services, a lot having to do with transit and bikes and peds. We also looked at what we called operations strategies, so things like eco-driving, transportation systems management, traffic clearance programs, and so on. Some demand management kinds of strategies like telecommuting, and then we looked at some pricing strategies as well. So for each of these strategies, we went out and looked at what was in the literature, what studies were out there that provided evidence about the effectiveness of these strategies. We focused on what we call the peer review literature, the academic literature, where we academics peer review each other's work, and if it gets published in a peer-reviewed journal, you know, that means there's some quality control over what's getting published. But we did include some research reports not published in the peer review literature, those that we thought were filling a need not met by the peer review literature, and were of good enough quality to be included here. And then we did focus on reviews of the literature where those were available. So there has been work in some of these areas where other researchers have already looked at what is all the evidence out there. So we had a bunch of criteria for inclusion, what studies got included, and I'm not going to go through this in detail, but we were trying to find studies done in California where they existed, and more recent studies where they exist, and really to focus on what would be most relevant for our policy efforts here in California. And then, of course, what we're trying to get out of this is what we call an effect size. So we focused on the studies that produced or published numbers that would let us understand the effect size. And by that I mean the size of the effect of the strategy. So if you implement this strategy, here's a quantitative measure of the effect you would expect to see on, and as we'll see, most of these studies, the effect size was on vehicle miles traveled, VMT, rather than greenhouse gas emissions itself. Okay, so not all the studies out there that look at these various strategies actually give you the numbers you need to understand that effect size. So that narrowed down what we were looking at as well. All right, so here's what it looks like. And I should say this is all available on the web. There is a research brief for each one of these topics, and then a technical memo behind that research brief that goes into more detail about the studies that we looked at for each of these topics. And so here you can get a sense of what I mean by an effect size. So residential density, the effect size is, you look at a 1% increase in residential density. The studies say that that leads to, from a 0.05% decrease to a 0.19% decrease in vehicle miles traveled. So it's that relationship between, kind of how much strategy you're adopting and how much the vehicle miles traveled is going to change. Okay, so I don't want to get too much into these specific numbers here, and the work was done some time ago, so I'm not sure I could tell you very much about the specific numbers here. But you get you get the idea that we are seeing measurable effects of these strategies in the literature, in the empirical evidence. And for the most part, they're in the direction we would expect and hope for, so that's a good thing. But they also look kind of small. Okay, so that's something to keep in mind. And then this was the other set, that second list. These numbers look a little different because it's not such, the effects are all a little different, like, where it was implemented, this was the effect, or for the people who participated, this was the effect. So depending on what the strategy was, the way the effect size is measured looks a little different. So it's makes a little bit of apples and oranges, hard to compare these things. Okay. So then what does this all mean? Well, first, where do we go? Wrong button. A couple things to note, and then I'll kind of do an example of what all this might add up to. So different outcomes are reported for different strategies. Ultimately, the project was about trying to figure out what the impact of these strategies would be on greenhouse gas emissions. For most of these strategies, the studies focus on vehicle miles of travel, which means there's another step to think about is, okay, how would that change in vehicle miles traveled translate into greenhouse gas emissions? We did not actually do that sort of a conversion, but our research briefs talk about things you would want to think about in doing that conversion. And then there were a few strategies where the outcome was directly measured as either fuel consumption or greenhouse gas emissions, but it was really just a few of the strategies. And then there were also some strategies where they didn't even get to the point of measuring what's the effect. The studies don't get to the point of measuring what's the effect on vehicle miles traveled. So for example, most of the transit studies, what they're measuring is the effect of the improvements in transit on transit ridership. And the bicycle studies look at the effect of bicycle infrastructure on how much people are bicycling. And I bring this up because you can't necessarily directly translate changes in transit use or changes in bicycling directly into changes in VMT, because sometimes it's, more people bicycling, it's not necessarily substituting for driving. It may simply be additional travel that people are doing. So again, in the briefs, we don't answer this question, but we outline what are the kinds of things you want to think about in making that conversion. Which direction might it go? Okay, so that's an important caveat. And as I said, most of what the studies we looked at were focusing on was VMT, not GHG emissions. Okay, so now what do these numbers mean? We've looked at all the evidence. We've come out with this range of effect sizes. How would this translate into some statement about the effectiveness of the strategies that are going into these sustainable communities strategies? So proceed with caution here, big red flags. This is a totally hypothetical example, but to get a sense of how you might use these numbers. So let's look at the land use strategies. What if we were able to achieve a 1.5% increase in density by 2035? That's the kind of change in VMT you might expect, and so on down the line. So if we did a 1.5% increase in all of these aspects of land use, maybe we'd get to a total land use effect of minus 1.17% VMT. Okay, and what you should be asking yourself is, well, what does this even mean? Is this realistic? Is this kind of consistent with the policies we're talking about? That's, I'm not answering that question here. It's just if you could do that, that's the kind of effect you might see. And then we could do the same thing for the infrastructure strategies and transit service strategies. And here, my little hypothetical example, I got to minus 4.4% impact on VMT with lots of assumptions, including that thing I just noted. Here I'm assuming that all increase in transit or bicycling directly translates into a reduction in driving. Okay, so caution, this is completely hypothetical. All right, and then so on for the last list of things. So if we did some operational things, demand management, and pricing, what could we get to? I'll let you look at that for a minute. And then we could add that all up from those different sets of strategies, and in my little hypothetical example, we get to something like an 11% decrease in VMT if you do all of those sorts of things. So again, this is completely hypothetical. How realistic are these changes that I've plugged into this little exercise? That's a big question. But you know, I think it's pretty clear, even from this hypothetical example, that it will take a lot of different strategies to get to the kind of numbers that we're looking to policy-wise. So there's some questions about this, right? Completely hypothetical example. So let's talk about some of the caveats here. So I want to talk about context. Certainly context is going to matter. Are the effect size simply additive? I just added up these different effects to come up with my 11% reduction number. How realistic are these changes that I've plugged in, these changes in density, the implementation of these programs? Let's talk a little bit about that. And then I want to talk about how certain are the estimated effect sizes. In other words, how good really is the evidence that underlies these numbers. So the first thing is context. Of course, context matters. So if you implement ride-sharing service in an urban area, you're going to get a different sort of effect than if you implement ride-sharing service in a suburban or a more rural area. We know this. Unfortunately, we don't have enough studies for most of these strategies to really be able to sort out what is the effect of context. So we know context matters, but how much it changes that effect size. We just don't have enough evidence in most cases to really be able to say. Are the effects additive? Well, probably kind of in general, but if strategies overlap to any degree, which they sometimes do, so for example, higher densities almost always come with more mixed use. So if we simply add the separately estimated effects for those strategies, we're probably overestimating the effect of doing both of those things. Conversely, if the strategies are complementary, like, what have I got there? Car sharing and parking pricing, if you're doing both of those things at the same time, they may be very complementary so that you get more of an effect than each one on its own added together. Okay, so the relationship between the strategies is going to affect the total effect size when you do things together. Okay, then the question about how realistic are these changes? So that 1.5% change in density I plugged in and so on and so forth. Well, one thing that, I don't know why it took me and Marlon some time to figure this out, Marlon and I. The research is almost entirely about, can you all hear me back there with the kids outside? Thank you. For example, when we're looking at these land use strategies, the research shows us how some characteristic of the built environment is tied to travel behavior. But that's not the same as looking at how the adoption of a policy is tied to travel behavior. So in other words, we have a lot of research over here that makes this connection. But this connection is also important, right? We need to know something about how the adoption of a policy, how effective that is in changing the built environment, which then changes the behavior. And we have much less research about the effectiveness of, for example, local land use policies in really bringing about the kind of change in that local environment that we need to reduce VMT and greenhouse gas emissions. And maybe that's obvious to you all, but I don't know. It was a light bulb that went on when we finally figured that out. And then for some of these other kind of programs like demand management, the same sort of thing. So we've got a lot of evidence about if you participate in a car sharing program, what is that going to mean for your driving? Or at least we have some evidence about this. But what about upstream of that? We don't know a lot about how different local policies would then affect participation in the program, which then affects behavior. So it's like we need another layer of research to really understand the connection between the policy and what's happening with VMT. Okay, and then how good is the evidence? This is, of course, maybe the really big question. Please do not cite this particular slide because this was not very systematically done, but this was my kind of quick, this is where the evidence falls in terms of quality. But you can think in terms of very strong evidence to very weak evidence, in terms of the numbers of studies available, the quality of studies available, and the consistency of results that they're producing. So I do think there are strategies where we've got pretty strong evidence that the evidence we see is reliable and rigorous and consistent. Doesn't mean it's not without problems, and I'm going to talk about those momentarily. But there are quite a few strategies where we still just don't have a lot of research yet, because some of this stuff is happening, now. Hasn't been around a whole lot. Hey, you're taking a picture. Be careful with citing this. Yeah, it's a different world with phones on. Yeah. Okay. Yeah, I need a big caution. Do not cite. Okay. Anyway, so there are strategies where we just, either they're newer strategies or they're harder to study or people just haven't done the research yet, but the evidence is pretty thin. So you need to keep in mind that when looking at different strategies. But let's talk about some of the issues even with the strongest evidence. So the land use strategies, we have a lot of research, lots and lots of studies, some of my own, some by people like Reed Ewing and Robert Severo. For the most part, that research is cross-sectional research design. So it's one point in time, and what the study does is compare one place to another. So we see that in a suburban sort of place, there's more driving. And in a more urban place, there's less driving and more walking. Okay, that's what we call cross-sectional. It's showing us that there's an association between the built environment and the travel behavior. And it's a very strong association. We've really established this. The problem is that we don't want to just know that there's an association. We want to know that there's a causal effect, that the built environment is what's causing that behavior. In other words, that a change in the built environment, which is what we're talking about, let's make places denser and more mixed use and all of that, that a change in the environment leads to a change in the behavior. That if we change the community, we will see a change in the behavior. And the studies are not directly showing us that. They're showing us that the environment is associated with the behavior, but they're not studying the change in an environment and the change in the behavior. And the problem is self-selection is how we talk about this. The likelihood that, that your preferences and habits and inclinations for how you travel influence where you choose to live. So that it's not really so much about the built environment shaping your behavior, it's really about your preferences leading you to live in a particular kind of environment that supports the behavior that you want to do. And the research shows that this is to some extent going on, so that people who prefer to drive, people who are living in the suburbs are people who prefer to drive. And people living in urban environments are people who have a greater preference for walking or biking or transit. Okay, so it just means if this self-selection is going on to some degree, that you've got to be careful in using the numbers that come out of those cross-sectional studies, because those those have not accounted for the fact that some of this is about preferences. It's not just about the built environment that we're giving people. We've known this for a long time. There was a very important report that came out. It may now be a decade or so old, but if you haven't looked at this, and this is a topic you're interested in and working on, I suggest looking at this Transportation Research Board, where they reviewed the evidence at that point on what we know about the connection between land use and travel behavior. And what they called for in the end are what we call natural experiments, intervention studies, policy evaluation studies, studies that actually measure a change in the environment and then look at the change in behavior. We have examples of those kind of studies that are a more experimental design for things like travel demand management programs. So there are studies that look at how much people are driving, workers are driving, then they go into a telecommuting program. How much does that change the amount of driving that they do? Car sharing, employer trip reduction programs, same sort of studies are available. So that's great. We have that kind of evidence for these kinds of strategies. But the problem is these tend to be little pilot programs that get studied. So there are a few of them in a few places with a small set of people. And we don't have a lot of good research on how does telecommuting affect things more broadly in a community. We've got some studies of natural experiments of implementing infrastructure of various sorts. Two examples I like very much are the Green Lane project led by Portland State, where they looked at the impact of investments in bicycle infrastructure on at least bicycling in the community. And then there's the Marlon Bournet, Doug Houston study funded by Air Resources Board, I think, and maybe Caltrans to some degree as well, that looked at the opening of the Expo line in LA. And they surveyed people before the line opened and asked them how much they were using transit, how much they were driving, how much they were walking. And then sometime after the line opened, they resurveyed those people to look at whether their behavior had changed or not. Were they driving less, using transit more? So that's the kind of study we really need to be doing to be more sure about the impacts of these kinds of strategies. We don't have a lot of these because they're very hard studies to do, and they take a lot of time. And you can be all set up to do one of these studies, and then the thing you're going to study gets delayed another couple of years. So these are really challenging for researchers to undertake, but I think it's very important for agencies to be thinking about this, that it would be very helpful to be funding not just the projects, but also data collection before and after the project so that we can be evaluating the effect of these strategies. So I think of it as building the evidence-based cycle. So we adopt a policy or implement a project. We need to be evaluating that, collecting the data that lets us do that, and then we can have a better estimate of what these likely effect sizes would be. And that will help inform the next round of policy. So that's my pitch for more research money. Okay, maybe I should stop and just say questions so far. Then I have a few. Okay, yeah.
One technical point of clarification on the VNT effect ranges. It's per capita or total VNT, and is it over a range of what's the range of time that you're looking at for implementing those measures?
In your hypotheticals, right?
In my hypotheticals, yeah, good point. Well, let's see. So you weren't supposed to ask me technical questions. No, I should know this. So Yeah, so if we went back to that, not even my hypothetical, but the actual effect sizes, I think, it depends on the strategy. And that's where the cross-sectional nature of the studies becomes important, because they're not really getting at that, like the land use ones don't really get at the time effect, because they're just looking at one place versus another today. And we don't have very many, if any, studies that look at, okay, density increased 2% over a 10-year period, and that led to a 1% decrease in VMT over that period. So I think we don't have a very good sense of that time effect for most of these strategies. Does that help? Yeah, right. Yeah, so if you could instantly become that other city, double your density. And that, that gets back to how realistic are these changes? Like, talking about a change in density, that doesn't happen overnight. So how long, what's realistic in terms of how much you can change density over what period of time? Yeah, we don't have research that, I would say we don't really have research that tells us that.
Would it be possible to study, the causal relations if there are multiple causes leading to a single effect? Like, say, for example, the common example we can go to sprawl, right? So sprawl occurs because, the city has approved housing. There's availability of water and infrastructure and highways, and so there are like 5 to 10 different causes, which ultimately results in sprawl. So how would you have a research designed to study those causes? I mean, how can you single out one cause over the other in such multiple causes leading to one?
Yeah, that's a good question. And it's you're talking about that kind of upfront part of what I laid out. So policies as they affect the built environment. We have the same issue for characteristics of the environment that affect behavior, because you get multiple things at the same time. There's density, how dense is it? How mixed use is it? What kind of transit service does it have? And those things all go together in a package, and it's that package that influences the behavior. So that's another challenge with the research, is how do you sort out which piece of that package is most important to affecting behavior? And I think the answer in both cases is more research, but big studies where you can vary all of those things, right? You need to do it in a whole lot of places to understand the effects of the different pieces. Yeah, it's like, we sample a lot of people, but we need to sample more places to get at that.
I was just wondering, so for car insurance, you have to list how many you're changing mileage over the year. Are there any studies where you've looked at citing and that data set? Is that a data set that's available for research?
Well, there are people who work with the DMV data on mileage, and I don't do that work myself, but Deborah Salon, who was at Davis and is now in Arizona, and we have an economist at Davis who, yes, thank you, yes. So I think ARB is funding some of that work.
Mostly with bar funding, honestly.
With
Bureau of Automotive Repair.
Oh, okay. Yeah, so that's sort of, yeah, there is data like that out there, but you don't have a lot of, and people have put that data together with data about land use. So you can look at, but again, that's a cross-sectional study. It shows you what's the association between the characteristics of the environment and how much people are driving. So we know that in central San Francisco, people are driving a lot less than they are out in the suburbs. And Deborah Salon's done some really nice modeling to show how those relationships work. But again, it's cross-sectional. So it's...
That individual in their case?
Yeah, has anybody done that in a time series sort of way? Some of the challenge with data like that is the confidentiality, so we don't know a lot about people or necessarily exactly where they live And I don't know if anybody's had kind of linked, the same person over some period of time. But if they're not then it's tricky because if they're not moving, but maybe you could use that to look if people have moved and their environment changes, but then you don't know why they moved, and maybe the environment changes, but their behavior is changing not because they moved, but because they had a baby. So it's, when you sit down to really sort it all out, it's really complicated to figure out what is the effect of this one thing on what people are doing. Okay, so I'm going to go on a bit. I have a few more points I wanted to throw out here. So there are limitations with the evidence, but I don't want you leaving here thinking we have no evidence to support this approach. There is really good evidence on some of these things, less evidence on others. But overall, it is certainly pointing to the effectiveness of these strategies in reducing VMT and greenhouse gas emissions to some extent. And it's nailing down that to what extent that's the challenge, given all of these caveats that I've gone through. But I think the other message to walk away from is that what it does point to is the need for a multifaceted approach, that the kind of effect sizes we're seeing for these strategies, none of them are huge. There's no clear silver bullet here, as we say, and that really we need to do all of these things together. And these strategies are, a lot of them are very complementary, right? So we may get even more bang for the buck if we do this set of things together. So I think that's, for me, that's another takeaway from this evidence, is that you've really got to do a bunch of things at the same time. A multifaceted strategy would make it possible to drive less. We can't expect people to drive less unless we make that possible. And that's where the land use strategies and transit and bicycle and pedestrian investments are really important. But just making it possible to drive less doesn't mean people will do it, and it always amazes me that Davis doesn't have more biking than it does, given what wonderful infrastructure we have there. So there's also a need to encourage people to drive less, so that's where the demand management strategies come in, but especially the pricing strategies. If we really do need people to be driving less, we've got to give them a little push. You can think of this as, we could use a carrot or a stick. Probably we need to do some of both here. And then, of course, the other strategies we're working on are reducing the impact of driving when people do drive, because, of course, we're all going to continue to drive to some extent. So we looked at various operational strategies and their effectiveness in reducing emissions when people are driving. So, of course, that's an important part of it, too. Now, here's what I want to throw in. What about expanding roads? Does this fit into a multifaceted strategy for reducing GHG emissions from transportation? So this was also one of the strategies we looked at. What is the effect of highway expansion in particular? The theory here is that, when you've got stop and go traffic, you probably all know this better than I, that, that makes vehicles less efficient and you're spitting out more emissions. So congestion contributing to the problem, let's reduce congestion by expanding capacity, and that will, that could be a strategy for reducing GHG emissions. So what happens when we add capacity? This is how I explain it. What happens in the short run? You have new capacity. You get faster speeds, so that may have a good effect from an emissions standpoint. But you also get shorter travel times, which people like. That's a very positive thing. And that means, what do? If speeds are faster, they may make farther trips, pick a more distant destination. They may make more trips. They may take more trips by car, shift from bikes, walking, transit to cars. And of course, that feeds back and creates pressure for more new capacity. Okay, so that's kind of a short run thing. The economists would explain it using supply and demand curves. So you can remember back to Econ 101, it really is about supply and demand. So, as driving time goes down, we demand more driving. On the supply side, as driving goes up, speeds slow down, it becomes more costly. And the volume of traffic that we observe depends on where this supply and demand curve cross, right? Now, what happens when you add capacity? What are you doing in economic terms? You are, if you were my class, I would make you answer. You are shifting the supply curve. Okay, so at the same volume of traffic, speeds are faster. The cost of driving is lower. And so what you end up with is a new crossing of the supply and demand curve, and you get an increase in the volume of driving because driving has gotten cheaper. And this is what we call induced travel. So there's a lot of discussion floating around out there now about this concept. And then we can also think about it in the long run. So that's kind of a short-term effect. We adjust our daily choices about travel in such a way that it's going to add to how much driving there is. In the long run, there's also another effect where we add new capacity. Things are faster. That increases the access to different pieces of land that are served by this facility, which makes that land more developable, and depending on local land use policies, could then trigger development in those areas, which of course could mean more population coming into the region, which of course means more driving. And again, that then feeds back and creates this cycle where we push for more capacity. So with my supply and demand curves, we've already shifted the supply curve. In the long run, we may also be shifting the demand curve by bringing more growth to that area. And then again, we end up with more driving as a result of that expansion of the highway capacity. So we also looked at the evidence on this topic, this induced travel question, as we label it, and found, again, this is a very difficult thing to study in a rigorous way. We focused on the studies that we thought were best, and they use different methods, and they use data from different areas. Some are one particular region, some use national data. But the findings are pretty consistent, and they pretty clearly point to some level of this induced travel effect. So the studies suggest that in the short run, a 10% capacity expansion is likely to increase vehicle miles traveled by 3% to 6%. Okay, so you're accommodating more travel, which could be a positive thing for the community from an economic standpoint. But some of the benefit to congestion reduction is offset by this increase in travel. And then in the long run, the study suggests that the effect might be as much as 6 to 10%. So in other words, in the long run, 7 to 10 years, you may be back to where you started in terms of levels of congestion, at least at peak hours. So you are accommodating more travel, and again, maybe that's the goal, but in terms of a congestion effect and thus an effect on emissions, you haven't gained much. And the really just crazy example of this that was in the paper recently is Houston, the Katy Freeway, which is supposedly the widest freeway in the US, where even in Texas they're starting to understand that continuing to expand the highways is really not getting them out of the congestion problem. So that's my induced travel diatribe.
Thanks, Susan. Can you extrapolate that data to things like roadway improvements, operational strategies, traffic light synchronizing, things like that?
Yeah, that's also a very good question. So most of this research is based on highways, focused on highway capacity expansion. But there is plenty of good reason to think that any sort of capacity expansion could have some of this effect. That has not been so much studied. I think it's just, it's hard enough to do this, harder to do it on a smaller scale and kind of separate things out. But yeah, I mean, the general economic principle that if you're reducing the time cost of travel, you are likely to be encouraging more of it. And we talk about some of this in our briefs because this is more of an issue for some strategies than others. But even, like secondary and tertiary effects, if you're getting people out of the cars and onto transit, then there's also a little bit of that. You've made driving a little bit easier. So then that's going to have some rebound effect on a little bit more driving because of the increase in transit. So, but we just, we don't really have the evidence to sort out to what degree that really happens. But I do think there's very good reason to think that anytime you're improving the speed of travel, you're going to have a bit of this effect, assuming enough demand. There was one back there, and then I'll come here. Yeah.
I think you had said that most of these studies are based on empirical data rather than modeling.
Right. So I'm only looking at the empirical data here.
So that being the case, I think you had a category for mileage-based user fee or some sort of pricing, and it was less of an effect than I would have expected if I saw the number correctly. But have you looked at all, are there any examples where there's a combination of pricing and capacity expansion to sort of counterbalance each other?
Well, we have the high occupancy toll lanes where we're pricing the new capacity. But in terms of taking existing roads, adding capacity, and pricing at the same time, we haven't done that in the US, as far as I know.
Extrapolate anything from the price?
Yeah. Well, that would be, so you could be speeding up the travel time, but if you're adding monetary cost, you might be able to balance it out so that you don't then get an increase in the volume. Is that what you're thinking?
Yeah, I just wasn't sure if there's any empirical studies on those priced HOV lanes and how that impacts the demands after construction.
Yeah, so I was asked about this not that long ago, and there's not a lot out there. There's more on just general highway capacity expansion, and the evidence on that special expansion is pretty thin. And I don't know off the top of my head what it says.
Thank you.
Yeah, and then the question.
Sure. I often wondered whether you could distinguish between sort of expanding capacity across a dense urban area separately from the sort of transition from the urbs out to the suburbs or new development. Could it have the reverse effect, making the city more attractive, improve travel times and so on, and get people to move to the denser environment?
Yeah, interesting question. We know historically, like when we built that interstate system that served the center city and the suburbs, that it made it easier for people to live. What? Yeah, live outside of and come back in. But I guess I don't see a clear theoretical way that would happen, that it would actually get people to move back into the city by making it quicker to travel from the suburbs, unless your job is in the suburbs.
Take the suburbs out of the equation. Let's look at San Francisco. Say you did it from just within the city limits. So you would have cross-town. You would improve cross-town traffic.
Yeah, within the city.
It would be more attractive.
Yeah, if it were easier to get around within San Francisco, it would be a nicer place to live. Yeah. I guess it's possible, but nice if we could do that using transit and biking rather than making it easier for cars. Yeah, and I don't know if anybody's studied that. I
was wondering if you can extrapolate that for capacity reduction, because that's a strategy that goes on.
Right. Yeah. Fun question. So capacity reduction. Not as much studied because we don't do it very often, but there are a couple of little examples that suggest that the concern is that if you take out capacity, you're going to make traffic awful, right? So this was the concern in San Francisco when they, after the earthquake, ended up taking out parts of their freeways. And in fact, the congestion problem didn't happen. And it does appear that some vehicle travel went somewhere else or went away because it wasn't, you didn't get these incredibly congested conditions in those areas. So not as well studied, but yeah, I mean, again, theoretically, you would expect it to work in that way. Yeah.
Have there been any studies to study the relation between the number of building permits by, kind of like a suburbia city and the increase in traffic, from those cities to downtown areas? I mean, we live in this area, Sacramento, so I can clearly see Roseville and Folsom, the number of building permits in the last 10, 15 years, and the traffic on, say, US 50 or, Interstate 80.
Yeah, so I'm sure there's been work like that, although I'm a little fuzzy at the end of the week here. Yeah, I mean, certainly we've tracked maybe not as specifically as numbers of building permits and then congestion levels, but certainly, land development and traffic. People have looked at that over time. Yeah, I mean, we know if there are more people, yeah,
between the number of building permits and the traffic.
The increase, so that, the change in development and,
Probably resulting in traffic congestion.
Yeah.
Although VMT has been traditionally used as a proxy to calculating greenhouse gas emission, but that relationship in long term is weakened. I don't know whether you have considered that factor in your analysis, because that has a strategy and policy implications which entirely changes the equation in long term. Although in short and medium term, the relationship is still strong. In long term, it is not as strong as some statistics suggest. By 2030 or 35, 50% of the fleet would be electric or some other vehicle that with zero emissions. Therefore, equating emissions and VMT in long term is not as strong as otherwise stated.
So as I noted here, most of the studies we look at VMT. So that was, in most cases, that was our focus. If it was a strategy where the studies did look at emissions, so the traffic operations topics, those studies, they measure the effect on emissions. Then we reported that. So yeah, the translation from VMT into emissions is not always straightforward either, and depends on a lot of things and probably will be changing over time. So we talk about that a bit in our research briefs, but we don't actually do that calculation or that analysis. So yeah, somebody else has to figure that out. Okay, so I think just to wrap up, I have a couple of quick little points. The other thing we know, of course, is that a multifaceted approach is going to take action at all levels of government. So you all know this, but I talk about this to other people. And then I think, one thing that helps all of this along is that, of course, there are countless co-benefits of most of these strategies that we reviewed. And again, that was sort of beyond the scope of what we were doing to look at the evidence on those co-benefits, but we do outline the likely co-benefits for the different strategies. So even if the effect on VMT and emissions is kind of small, communities can look to these other co-benefits as a way to justify those kinds of approaches if they need to. And of course, all of these co-benefits ultimately translate into a pile of dollars, at least most of them. So that's a very good thing for communities. So that's what I wanted to share. Thank you.
Well, thank you again, Susan. I think all of us can agree that was really informative presentation. I know, Susan, you have somewhere to go, but you have to go back to UC Davis, but you might be here in case people want to grab her afterwards just for a little bit. I just want to announce that there is another upcoming forum on next Friday, and it will be in the same room at 12. Lunch will be provided, and it's on firearm violence. And so you can again RSVP with Tammy. Tammy's in the back if you would like to come join us next Friday. And again, lunches are in 125, and just thank you again for being here today. Really appreciate it.
Yeah, great questions. Thank you all.